Hello everyone, my name is Gaurav. I am a member of the PyTorch team at Facebook, where we are working to democratize AI for internal and external uses. Today, I'll talk to you about PyTorch Mobile and how that helps you to go from research to production at scale. First, let me start with a brief introduction to PyTorch itself before going deeper into the edge compute and mobile portion that will be the focus of our talk today. PyTorch is an open source project for machine learning training and inference. It is a very popular project with more than 1,500 contributors and 40,000 users on GitHub. Many ML researchers and engineers around the world are part of this growing community. So what are some of the key design principles that have guided the architecture of Python? First is support of eager execution through Pythonic programming. Additionally, there is a graph mode execution mode for efficient inference. There is also support for dynamic neural networks that allows execution of models with control flows and variable data lengths, such as the ones used in NLP, translation, etc. Third, PyTorch supports distributed learning for computationally expensive models and large-scale datasets. Fourth, PyTorch has worked with partners to support hardware accelerators, which helps achieve better perf per watt per dollar and bring larger efficiency for data centers. Finally, PyTorch emphasizes a single elegant way to do things. This reduces cognitive overhead and accelerates developer efficiency. PyTorch has always focused on the developer delight and provides freedom for researchers to iterate quickly and come up with the best models. The APIs are clean and easy to use. PyTorch offers an ever-increasing set of tools and libraries that the developer can use in their journey to take their model from research to production. We are now nearing 1,500 contributors on GitHub, which is almost 50% growth in the community year over year. Tons of people use PyTorch. The most interesting thing for me is the breadth of the community members. We have maintainers in the project from Facebook, Microsoft, Google, Amazon, Tesla, Uber, CMU, MIT, and many more. Seeing people come together over a common passion for building the best platform to advance AI is just so awesome for me. Okay, in terms of deployment, PyTorch can be deployed in many ways depending upon your production environment. This chart is indicative only and perhaps an oversimplification. However, it'll give you a good sense of where things are. On the left, you will notice that PyTorch is deployed on data centers in the cloud. On the right side, we show the two different routes to take PyTorch models to mobile deployment. The most popular mechanism is via the PyTorch Mobile interpreter that provides a runtime to dispatch the operators to appropriate hardware backends such as CPU, GPU, DSP, and NPU. This mechanism is the focus for today's presentation. Additionally, there is an experimental route of using the TVM compiler via an ONNX conversion that produces code for CPU by utilizing ARM LLVM. In the context of this mobile deployment, PyTorch Mobile is now the ML inference platform of choice inside Facebook. It powers new AI use cases in Facebook family of apps for both iOS and Android, and is in large-scale production already. It is additionally used by Facebook-developed hardware like Oculus VR headsets and Portal communication devices. Next, I would like to give an overview of the PyTorch Mobile framework. Many people ask us what is PyTorch Mobile and if it is a separate framework from the core PyTorch. The quick answer is no. It's still the PyTorch you know and love. We believe that we don't need to build a new framework to take your AI models to edge deployment. We developed a framework where we don't need to do model conversion or port operators. PyTorch Mobile is part of this unified framework that lets you quickly bring your ideas from research and prototyping to production and deployment on edge devices. So what can PyTorch Mobile run? As expected, we only support a subset of Python. Since supporting entire Python on a mobile device wouldn't be performant or footprint friendly, or even relevant for that matter. PyTorch Mobile is built on top of TorchScript, which is a large subset of Python. We support all data types and control flow constructs of TorchScript, such as loops, functions, tuples, and name tuples. You can continue to think of your model as a program. Many Python features apply directly to TorchScript, even if we don't directly support all of Python. TorchScript supports the use of most Python functions and many Python built-ins. So how does it work in real life? You would train your model in Python and save to a TorchScript model. This mobile-friendly TorchScript file can now be taken to your mobile workflow. The TorchScript model can be loaded by code that has no Python dependency. This means that there is no global interpreter log. How cool is that? Which means we can also enable multi-threading that is ideal for production environments on multi-core compute backends. I will note though that we don't support eager mode on mobile, as that wouldn't be very production friendly for edge devices. Okay, now let's talk about how might a model run on the mobile hardware. PyTorch supports multiple hardware backends. The runtime executes models on CPU via libraries that are highly optimized for ARM CPU. PyTorch uses XNNPACK for float operators and QNNPACK for quantized operators. Both of these libraries have been optimized and they run many kernels in a very optimized manner. GPU is supported via Vulkan-based operator libraries and is under development. As you know, that many recent SoC now include DSP and custom deep learning accelerators, also known as NPU. PyTorch supports export of the model to Android NN API and execution on these DSP and NPU via the vendor-provided HAL included in Android builds. PyTorch support for iOS is very similar to that we saw for Android. CPU support is via XNNPACK and QNNPACK. Again, the highly optimized libraries for ARM CPU and other CPU. We are also working actively to add support for GPU and Apple devices via Metal, which is very similar in principle to the Vulkan-based design for Android. Separately, there is an export path available that lets you execute the model on the neural engine by utilizing Core ML framework. Now let us talk more about typical workflow to go from research to production. The essential elements are shown in the indicative high-level flowchart. Once you have a PyTorch model, you can optionally quantize the model from float to lower bit precision, such as int8. After that, you can script or trace the model, followed by optimization for mobile inference. You can then save the model to generate the model file. This file can then be loaded by the app on your mobile device, which we will discuss next. Without the optional model quantization and optimization steps, there are really only two two steps required for you to generate the model file for mobile usage. You script the model, and then you save the model to a model file, as shown in this simple code. Next, you load this model file on the mobile app, and for this, you really need a few lines of code to get going. First, we need to add a dependency on PyTorch to bring the pre-built binaries for your mobile app. For Android, you can use a Java wrapper for libtorch, which allows you to continue to build your Android apps in Java and not worry about NDK. On iOS, you can use Objective-C++ to make calls into the C++ libtorch API. The code for Android and iOS looks pretty much the same. You get your feature vector, you then create a tensor from this input feature vector, you run the model, the forward function, and then extract the output vector from the generated tensor. That's all there is to it. Okay, so now I just want to show you what optimizations are possible and what's the benefit of them. Some sample optimizations can be applied to your model on the host before you save it for mobile usage. This newly added optimize for mobile function call can do a lot of heavy lifting for you. It can fuse con2d with batch norm2d. It can transform ops for xn_pack, fuse relu hard_tanh with con2d, remove dropout, etc. We do plan to continue adding more optimization passes and provide incremental benefits. In addition, we recently added support for channels last format. Data packing format is critical for kernel efficiency as it impacts cache access pattern and utilization of CPU ISA. If your data is not initially packed in NHWC format, then converting it to NCHW will take additional processing cycles, but in the end, there is more saving in the actual compute kernels, especially when using xn_pack library on CPU. These various optimization tools that we just talked about, both the optimize for mobile passes as well as channels last format and other improvements in the framework in multi-threading and using pthread pool, have actually varying amounts of benefits on different models. We have observed some models like MobileNet V2 to run up to 6 times faster now compared to earlier PyTorch 1.4 release. Okay, quantization. Model quantization is very useful for mobile devices where both storage space and memory bandwidth are at a premium. Quantization leads to 4x reduction in memory usage and often gives significant boost in throughput. PyTorch offers 3 turnkey mechanisms to quantize models. Each method has its own advantages given the model type and your workflow. We offer post-training dynamic quantization, where the data exchange between ops is still floating point and is suited for networks such as LSTM. Second is post-training static quantization, where both weights and activation are quantized to int8 and works well for CNNs. Third is quantization-aware training, which provides the best accuracy for all model types. Quantization is now being used very effectively on a wide variety of models within Facebook. The reduction in memory bandwidth combined with optimal use of ARM Neon ISA leads to 2 to 7x speed up in model execution. Of course, the space savings for memory and memory bandwidth is roughly 4x. The accompanying loss in accuracy is often just fractional percent points and typically acceptable for most use cases. We also have a very useful technique for reducing the binary size of PyTorch libraries. The final size of a mobile app is crucial for mobile developers as well as the end user. We introduced a selective build mechanism to exclude any PyTorch operator that is not required by the mobile model executing in the app. An offline pass can be used to prepare a list of operators that are required by that particular model. This list can then be given to the respective build scripts for iOS and Android. The build script will ensure that only required ops are included in the library being built and other operators are excluded. This can really help save hundreds of kilobytes or more from the final binary that runs on the edge device. I just wanted to mention a recent exciting use of PyTorch on mobile phones. Facebook launched 3D photo feature in 2018. This was a new immersive format for sharing pictures with friends and family. The feature relied on the dual lens camera available in new higher-end smartphones. As such, the feature hasn't been available on typical mobile phones, which only have a single rear-facing camera. We recently used state-of-the-art machine learning techniques to produce 3D photos from virtually any standard 2D picture, and that this deep learning model running on an iOS and Android phone can now infer the 3D structure of any image from a single 2D photo that you take and can share with your friends as a 3D photo that is engaging and compelling. I want to next talk about PyTorch features and availability. PyTorch 1.6 was released in July. This is a beta release for PyTorch Mobile, which means we are committed to taking all of these features over to a stable version. However, we're not committed to backward compatibility, and some APIs or Perf characteristics might change going forward. The next release for PyTorch 1.7 is expected in the next few weeks, and will add support for GPU backend for Android and the NNAPI export path for DSP and NPU backends that I discussed earlier. We do expect PyTorch Mobile to be a stable release next year. That version will bring support for iOS GPU, as well as new tools and improved runtime to make the binary size even smaller than it is today. I hope that gives you an idea of current features and capabilities of PyTorch and how it can help you take your research into production. We feel that PyTorch can help you build compelling and engaging products for your end customers. I would like to leave you with a few additional pointers to help you in this journey. You can please start with our main webpage, pytorch.org. It has been recently updated to include many tutorials, recipes, as well as pointers to a couple of YouTube videos to help you take your models from research to production. There are quite a few online courses available that provide the foundation and help you get started. Udacity has a great Intro to Deep Learning course where it teaches you how to get going on deep learning with PyTorch. Fast.ai is another great website with lots of useful material and courses available. I would also like to point out that PyTorch is now available in Chinese, and there is a large community in Asia that's utilizing the resources on this website, and I ask you to check it out if you're interested. Well, there's Korean as well. Feel free to engage with this large community in the APAC region who's super active on PyTorch. We've mentioned community a lot throughout this talk. Please do check out the PyTorch community and join the conversation or just listen in. A lot of brilliant people participate, publish, research, code or are just there to help users solve their problems. Please engage with us. Tell us how you use PyTorch, how you think it can benefit you, what is missing, what would you like to see. We are there for you. Please engage with the community, reach out to us. I hope you found this talk useful and engaging. I would like to take the time to answer any questions and hear from you as to how you've been using PyTorch recently. Thank you for coming.